The diagram shows a square ABCD with sides of length 20 centimetres. It also shows a semicircle and an arc of a circle. AB is the diameter of the semicircle, AC is an arc of a circle with centre B. Show that the area of the shaded region divided by the area of the square is equal to pi divided by 8. So for this question, the first thing we'll need to do is work out the area of this shaded region here. Now to do this we can work out the full area of this quarter circle ACB and then minus the area of this semicircle from the full area. So the formula for the area of a circle is pi r squared. So this means that the formula for a quarter of a circle will be pi r squared divided by 4. So because ABCD is a square, then this means that all of the side lengths will be the same. So length BC will also be 20 centimetres. And this means that the radius of this quarter circle is 20 centimetres. So we can substitute this value into the area of a circle. So the area of ACB will be equal to pi multiplied by the radius, which is 20, squared. And then because this is a quarter circle, we can divide this all by 4. So the first thing we'll need to do to simplify this down is square the 20. And 20 squared is equal to 400. And then the final thing we'll need to do is simplify down this fraction. And pi multiplied by 400 divided by 4 will give us 100 pi. Now the next thing we'll need to do is work out the area of this semicircle here. Now the area of a semicircle will be equal to the area of a circle divided by 2, because a semicircle is half of a circle. Now an important thing to remember is we need to use the radius to work out the area of a circle. However, 20 centimetres is the full diameter of this semicircle. So the radius will be equal to a half of this length, which will be 10 centimetres. So now we need to substitute 10 centimetres into the area of this circle. And this gives us pi multiplied by 10 squared, and because it is a semicircle, we'll want to divide this by 2. Next we'll need to simplify this down, so as before we'll first square the 10, which gives us pi multiplied by 100, all divided by 2, and then pi multiplied by 100 divided by 2 will give us 50 pi. So now if we look back at the diagram, we've worked out the full area of this quarter circle and we've worked out the area of this semicircle. So the area of the shaded region will be 100 pi minus 50 pi. And 100 pi minus 50 pi is equal to 50 pi. So now the final thing we need to do, in order to show that the area of the shaded region divided by the area of the square is pi over 8, we'll need to work out the area of the square. So the area of a square is equal to base multiplied by height. And if we look at our square, this will be equal to 20 multiplied by 20. So this means the area of the square will be equal to 20 multiplied by 20, which gives us 400. So now the final thing we need to do is substitute in these two values into this fraction which we've been told to prove in order to show it's equal to pi divided by 8. So the area of the shaded region divided by the area of the square will be equal to 50 pi divided by 400. And if we simplify this down, We can first divide both the numerator and the denominator by 10, which gives us 5 pi over 40, and then we can divide both the numerator and the denominator by 5, which gives us pi over 8. So as we can see, we've shown that the area of the shaded region divided by the area of the square is equal to pi divided by 8. Now this question's worth 4 marks. We'll get our first mark for working out the area of the quarter circle. We'll get our second mark for working out the area of the semicircle. We'll get our third mark for working out the area of the shaded region and the area of the square. And we'll get our fourth mark for a full complete proof.